Well, hello. If you're here for the A-level maths class, thank you very much for joining me. If you're not here for that, then you've accidentally found an A-level maths class on vectors, and you're looking for like the next like TikTok superstar. It's not me. So if you're there, you're in the wrong place. But if you're here to learn some stuff about vectors, to revise some stuff about vectors, to cover some stuff about vectors, then that's what we're going to do. We're going to do some stuff about vectors. I'm going to launch into it. We've got an awful lot of stuff. It's going to be a whistle-stop tour today. It's going to be covering as much as I can without really being too many exam questions, which is why in the description below, if you press show more, you can find the description which gives you a link to some questions where, because of the nature of A-level questions, those questions have got videos to go through each individual skill. But what I'm trying to do is give you a coverage of to allow you to access those videos, if that makes sense. If you do have any questions and you are here for the live stream, please do put them in the live chat. But I understand with the nature of A-level, Snapchat won't look after itself. Duties need calling, and Fortnite is being used, I imagine, as well. So look, if you're here and you've just come to watch this after the case, feel free to post any questions in the comments below the thing, and I will always try and respond to them as best I can. So let's get going. What is a vector? A vector is a distance with both direction and magnitude. That vector is the same as that vector in terms of the actual vector itself. It's got the same distance and the same direction. It doesn't matter if I move it up, down, left, right. It's the same vector. What that means is we can use vectors and combine them. We can have two vectors that can pass by each other that look like they should cross, but if we're in a 3D world, they don't actually touch, because if we look down there from that angle, they're nowhere near each other. But what we can know, that if we have a vector and it goes through a point that another vector goes through, so if we have a vector here and we have another vector, they are parallel. But if we're told that they go through the same point, we'll call that point P, that one goes to there, and that one goes to there, then they must form a straight line, because if two vectors have a point in common, let's make that a bit bigger, if they have a point in common, they must be part of the same straight line. So the first thing we're interested in is the magnitude and direction of a vector. And to do so, I'm going to take us over to my software over here. And in this software, we're going to start off by drawing a simple vector. Possibly not in highlighter, but we will switch to doing that in pen. Here we go. Simple vector. Now, this vector will have a measurement attached to it. Now, there are two ways we can write this. We could write 4, 3, or I can write this as 4i plus 3j. I and j are unit vectors in the direction of I and j. This is going 3 in this direction and 4 up from the origin, or from where it's starting. So we can say that this goes along 4 and up 3. Therefore, it shouldn't take too much imagination to realise that to find the length of this one, we have a 3, 4, 5 triangle. We can go the square root of 4 squared plus 3 squared, and we know this is 5. In fact, to find the magnitude of any vector, you're going to do the square root of x squared plus y squared. The two numbers themselves, or the numbers from the vector itself, squared, added together and square rooted, give you its magnitude. We can also find the angle from here. So the angle of the vector itself is going to be the angle between the number and the j number. So we're going to have tan theta is equal to whatever the I number is, 4, over the j number, 3. And we know that tan is okay with being different. So it's tan to the minus 1 of 4 over 3, giving us 53.1 degrees. Don't know why I've got 2 little dots there. So we've got 53.1 degrees. This is telling us that angle there is 53.1 degrees. And so it's the angle between the four. So when you've got 4i plus 3j, it's giving you that angle theta there. It's allowing you to have the direction, which is quite important. Okay, so I've done opposite over adjacent, so that was silly. Okay. Tan theta, as we know, is opposite over adjacent. So the angle we should be talking about is this one here. If it's 4 over 3, opposite over adjacent, we can see that that's 53.1 degrees. Okay, the reason being is it will also be that angle, and it gives you the angle from the vertical to where the angle is we're looking. Where would that angle be? It would be 53.1. Okay, and we're able to do that by using I over j. So what we've got here so far is that a vector has a magnitude and it also has an angle that can be created, and we've got this idea of I and j. Now what I really want to do is focus on what happens when we have got something called position vectors. Position vectors are always related to the origin. So if I've got 2 points, one here, it's quite a large point, but it will do for the, in fact, it's probably best if I just draw it. And we'll put this grid on to help us. So, if I've got 2 points, we'll call this one point Q, and this point R. If we're given position vectors, we know that we can find this is always O. So if we're told the position vector of Q is, let's say, 3, 8, or 3i plus 8j, and we're told that position vector of R is 10i plus 4j, so 10i, 4j. What those two things have given us there are OR and OQ. That line there is OR, and that is OQ. These are the position vectors of these two spaces. We can use these to find the vectors of the line it's from Q to R. And to do so, we have to imagine we are trying to travel from Q to R. If I'm travelling from Q to R, we don't know what QR is yet. That is what we're finding. So we need to travel backwards along the position vector OQ, then forwards along OR. So we're going to need to travel QO plus OR. This will always be the case. By drawing diagrams, you can always follow the route you need to take to work out what this vector is. This therefore says QO is going to be the absolute opposite of this. It's going to be what happens when we times this by minus 1. So it's going to be minus 1 times 3i plus 8j plus 10i plus 4j. You can do this either, you can do it by expanding the brackets and do it with i's and j's. You can also do it as minus 3 minus 8 plus 10, 4. This is from GCSE. You can, when you're multiplying, when you're adding your vectors together, top added together gives you 7, bottom added together gives you minus 4. So we can see QR must equal 7i minus 4j. 7i, and we call this the resultant QR, or the resultant of Q, O and OR. So some of the words we're needing to make sure that we're familiar with. If we're in year 12, we need to be familiar with magnitude. We need to be familiar with position vector. We need to be familiar with resultant. And just glancing down at my notes to make sure that's where we're up to so far. The next thing I'm going to talk to you about is two vectors that are linked to each other intrinsically. And that is what happens when they are parallel. When two vectors are parallel, maybe my finger and my arm, this vector is the same as this vector, but just multiplied and made longer. Possibly better if I use my finger and the pencil. We can see the pencil is longer, but it is the same direction. It's just a longer magnitude. So instead of saying they are the same vector, we're saying this is a multiple of that. If I take the length of the finger and multiply it by something, it's going to equal the same thing. To deal with that, we write that it is a scalar amount. So we can say that if this is A, and this is parallel, and it's B, but it's longer, we can say that B is an amount multiple of A. Now you'll notice I'm doing little hats on my A's. Often when they're written down you see them in bold, but it's very difficult for me to write in bold. I'd have to keep changing out from thick lines, thin line, thick lines. It's much easier to put a hat on them, and so I recommend you do the same, because writing in bold with a biro is difficult also. So, hopefully that has given you some understanding of what we've done so far. We have talked about the fact that one is a multiple of the other, and also on the board behind me I showed you that when there's a point in common, they form a straight line. Putting those two facts together, we can then find whether a line is straight based on whether it has a point in common and whether it's a multiple of another vector. For example, if I had the vectors AB and BC, and I found out that one was a multiple of the other, then the fact that they both contain B would mean, oh, it must make a straight line. Let me show you what I mean. What I've just talked about, let's say AB was equal to 6A plus 8B, and BC was equal to 9A plus 12B. And let's say B, just to avoid confusion here, I want to make it so that we're not using B as a multiplication factor, so we're going to put D here. and so D is the longer version. Otherwise it gets confusing. But we've also got a different direction, B. So that we've got A's and B's that we're talking about. 6 A's, 8 B's, 9 A's, 12 B's. Well, the thing we can do here is we can look at this and go, well, I believe AB is equal to 2 brackets 3A plus 4B. And I believe that BC is equal to 3 brackets 3A plus 4B. So as soon as I do that, I can see that they're both containing these multiples. Therefore, once we've got that they're both containing the same multiples, we can know that they're parallel. In fact, we can say that AB is equal to 2/3 of BC. Because that is BC and this is 2 of them instead of 3 of them. So we can say that everything. But the fact that because they share point B, they must also, ABC must be a straight line. So that's how you can tell lines are straight or not and tell whether they contain different straight lines. This has been very much a whistle-stop tour so far. Well done if you're keeping up with me. If you are here live or if you're here afterwards, hopefully you're understanding some of the different things I've done. The next thing I'm going to talk about is how we can talk about the vector equation of a line. The vector equation of a line. So I have 2 points. P1 is 3 minus 1 and P2 is equal to minus 1 minus 4. Let's put that in space. 3 minus 1 and minus 1, 4. Minus 4. And we are told that there is a line that goes through both P1 and P2. A line that goes through them both. Now these are position vectors. So another way of calling them is 3i minus 1j, and we've got minus 1 I minus 4j. So like we said before, in order to find, that's O from the O to P1 and O to P2, in order to have an equation, we need to get to the line and then have multiples of P1 to P2. So the equation of this line is going to look something like this. It's going to be OP plus an amount of P1, P2. We have to get to the line from O, then we have to do as many of these as we need to make that line, because it's going to be that line just moved over. So the first thing we're going to do is say, well, the OP we already know is 3i minus j. But we also have a multiple here of whatever P1, P2 is. So to do P1, P2, we've already done a similar question to this. We have to go backwards along P1, backwards along P10. So we've got P10. I probably should have used P and Q rather than P1 and P2. We're going to go PO plus OP2. PO is the backwards version, so it's minus 3 plus 1. OP is the forwards version, so it's minus 1, minus 4. Add them together, you get minus 4, and you get minus 3. So we've got here minus 4i minus 3j. So you've got that the equation, the vector equation of this line, is equal to that plus a multiple of this, because we don't know how long this line is and how long this vector is. That vector will be, the vector r will be that multiple, that position vector gets us there, and then it's going to be a multiple of whatever p1, p2 is. Obviously, it's pointing that way at the moment. So this is how you can do the vector equation of a line. Now, the second thing that comes about with vectors is 3D vectors. That takes place in year 13. I will do a future lesson on 3D vectors, which will talk about introducing K. It will talk about having 3D coordinates and the distance to the origin for them, and the angles between different lines, and the unit vectors themselves. If this has been useful, then please drop it a like. If there's any questions that have come about and you're not clear on anything, please do ask me in the comments below. I am more than happy to try and explain things a little bit further, to do some more worked questions. This is supposed to be introducing the topic for any year 12s who haven't yet done the vectors, any year 11s who are doing it next year, doing some extra stuff on vectors, trying to cover some of the different things, talking about magnitude, talking about position vectors, talking about resultants, getting people to draw the diagrams of what they're doing, and talking about how we get the equations of a line from it. I hope this has been useful. If not, my apologies. I've been Mr. Harris, and I will see you in the video on Wednesday, where we'll be looking at something else. Take care.